Okay, with it. Shall we start lesson? Container. If you're in the class, please give me a thumb. If you're in the class, please give me a thumb. Thank you. Thank you. Okay, with it. First, we can may start the theory lesson today. May after that, may we can move into the questions. Okay. Now we are discussing about horizontal circular motion. Horizontal circular motion today. We have discussed about several applications. Now our next application. Now our next application is rolling of a car. Rolling of a car at a bay. So you know, actually, sometimes you may see this scenario. So when there's a formula racing, uh, you may see this observations. Those cars where when taking the bends, sometimes those cars may roll into the outward direction of the bed. No? So this is something that kind of scenario. That means if we take a bend, sometimes there's a possibility of rolling. There's a possibility of rolling into the outward direction of the bin. There's a possibility of rolling of this car into the outward direction of the bin. So we are going to study about this scenario. We are going to study about this scenario. So if we consider about the plan view of the car. Now this is our car. There are 4 tires. Here there's one tire. Here there's another tire. There are 4 caps. And so if we consider actually there's a reaction. This is plan view. If we consider about the reaction between this tire and the rod, it will be perpendicular to this surface. Suppose this is S. S1. Mangana මෙතනින් reaction එක S2 here. ඊළඟ මෙතනින් reaction එක R1 then R2. Those are the perpendicular reaction between each tire and the rod. They are perpendicular to tire. We cannot mark the perpendicular because it is outward into the it is into the outside of this plane. That is the reason I have inclined this one into this direction. Then I can consider the resultant normal reaction. The resultant normal reaction of S1 and S2 is capital S, and definitely it should go in between them, and into this direction. Perpendicular. ඊළඟට I can take the result force of R1 and R2 as R, and it is into this direction. Okay. Now there are only two reaction forces. Now there are only two reaction forces. One is S, other one is R. One is S, other one is R. S, other one is R. Okay. Therefore, definitely the total reaction force should be the resultant force of R and S. The resultant force of R and S definitely should be start from this line. මේ line එක තමයි අනිවාර්යයෙන් start වෙන්න ඕනේ. මම ඒක මාක් කරන්න යන්නේ නැහැ මෙතන. අනිවාර්යෙන් තේරුම් ගන්න ඕනේ මේ දෙන්නගේ reaction එක තමයි the resultant normal reaction. The resultant normal reaction should go through this line. And start from this. Start from this line and go somewhere here. Therefore, definitely friction force should occur along this line today. Friction force should occur along this line into the center of the circle, because friction force and the total normal reaction should be at the same location. Therefore, friction force should go along this line. If you get that one, please raise the hand. If you get my explanation, please raise the hand. Take the note, sir. I need response from everyone. Those are the reaction and friction forces. Other than these forces, there will be mg. No, mg means it is weight. You know, if you consider about reaction forces, normal reaction forces are into the upward direction, while mg is into downward direction. Therefore, if you consider about reaction forces and weight, normal reaction forces are into the vertical upward direction, while the weight is into vertical downward direction. Therefore, definitely the weight should be in opposite direction. It should be in opposite direction, and they are parallel each other, but in opposite direction. Is that clear? This is plan view. Make a plan view. Plan view. If you got this one, please raise the hand. The plan view. This is mg. කොහොම හරි mg එක පැත්තකට අනිත් එක අනිත් පැත්තට තියෙන්න ඕනේ. එක කමන්න කොහොමද? හරි. Okay. මේක අනිත් පැත්තටවත් කමන්නේ මේක මෙහෙම ඇඳලා MG අනිත් පැත්තට ඇඳලා තෙත් කමන්නේ නේද? ඒක කමන්නේ. කොතරම් මම MG ඇඳලා තියෙන්නේ මෙතන ඉඳන් ඇතුළට යනවා වගේ තමයි ඇඳලා තියෙන්නේ. සමහරට එකපාරට ඔයගලන්ට ඔලුවට යනවන්න පුළුවන් මේ විදිහට. මෙතන ඉඳන් ඇතුළට යනවා නම් පුතේ මෙහෙම තියෙනවා. ඇතුළට යනවා. ඒ විදිහට ඇතුළට ඇත්තේ එක එකපාරට ඔලුවට නැති නිසා තමයි ඔලුවට යනවා. නොයි කියන නිසා තමයි මෙහෙම දැම්මේ. මේ ටිකට අනිවාර්යෙන් ඔපොසිට් වෙන්න ඕනේ. Rolling of a car at a bend. Then I can mark them in a vertical figure. So if I mark it in a vertical figure, those are towers. Therefore, S is in this side. Where the S. R is in outer side. So this is inside, inner side. Inner side. Here S. Outer side R. Then suppose this is the center of gravity and here the weight. And height to center of gravity is simple h, and this one is a. Okay. So we can consider several consideration here. First one is as this object, as this car moves in a circular road, definitely there should be a centripetal force into the direction of center. There should be a centripetal force into the direction of center. That centripetal force should be the friction puthe. Therefore, friction force should be into the direction of center. That is number one. Then this car does not have any vertical motion. It has no vertical motion. Therefore, its vertical forces should be balanced. It should be balanced. Is that clear? If it is clear, please raise the hand. You know how to start. The next point is if there is no rolling, the moment about center of gravity should be zero. If there is no rolling, the moment about center of gravity should be zero. Those are the three arguments. As it is moving in a circular path, definitely there should be centripetal force into the direction of center. That is number one. Vertically, it has no motion, therefore vertical forces should be in equilibrium. Number two, the third argument is if there's no rolling, there's no moment, therefore moment about center of gravity should be zero. Moment about center of gravity should be zero. Then I can use those three. apply F equal MA to this side. If I apply F equal MA to this side, then what may happen? F is equal friction force is equal M V squared over R. That is number one. M V squared over R. Then vertically, if I take vertical equilibrium, there are vertical forces S plus R. S plus R is equal mg. For capitalism. This is second equation. If you got this one, please raise the hand. The applications that you know to solve. Okay. Then the third application is taking moments. If I take in moments about G, G what S into A, S into A. මේක අනිත් පැත්තට පුතේ R into A minus R into A. මෙතන පුතේ තා friction force එක තියෙනවා. F into A මොකද තියෙන්නේ? S into A ඊළඟට minus R into A. මේක minus F into H. F into H should be 0. S into A into the clockwise direction. Sorry, make plus. F into A into the clockwise direction. F into H. That also into the clockwise direction. Then R into A into the anti-clockwise direction. Is that clear? If it is clear, please raise the hand. Take the other side. Therefore, if I take R minus S, R minus S should be equal F H over A. Therefore, R minus S should be F H over A. FH over A. And here F is equal mv squared over R. mv squared over R. And you can apply that thing here. Therefore, the S plus R is equal to G. That is number 2. You'll get R minus S is equal M V squared over R H over A. F M V squared over R, that is F, H over A. Then H over A. If you got this thing, please trace that. You don't know to solve probably. If you add them, whatever S2S will be cancelled out, then R is equal M common factor. Yes, M over 2 times G plus V square H over R. Correct. M over 2 times G plus V squared H over R. This is R. This is R. Then if I subtract this one from this, S is equal M over 2 times G minus V squared H over R. This is this. Is that clear? Then negative 2 plus 3. Here 2 minus 3. I need responses from everyone. If you got this, please raise hand. Yeah. Now we have taken the value of S and R. Now, Pute, look at this, my argument. Please listen to me, my argument. Please listen to my argument. This is very, very important. So if there is a rolling, this car should be rolled either in clockwise direction or anti-clockwise direction. There's only two options. If there is a rolling, definitely it either be clockwise or anti-clockwise direction. So if it is moving in clockwise direction, this tire will raise up. Then the contact between the tire and the road will be lost. Is that clear? If there's a movement into clockwise direction means outward direction to the Belguti. If there's this kind of movement, rolling. If car rolls into the clockwise direction, that means into the outward direction, definitely the contact between the inner tires, will be lost. That means S will be 0. Is that clear? If you got this one, please say that. I need responses from everyone. If there's a rolling into the clockwise direction, that means outward direction to the bin, definitely this tires will raise up while this tire in the contact. Definitely the contact between this tire and the rod will be lost with it. Therefore, definitely S should be 0. Is that clear? Now look at this one. If this car rolls into the other side, what will happen? If this car rolls into the other side, definitely these tires, that means inner tire, this is outer tire. Outer tires will press up with it. They will raise up. Therefore, contact between the outer tire and the rod will be lost. That means here R will be 0. Therefore, if there is a rolling into the outside inner tire, that means the reaction force between the inner tire and the surface or the rod will be lost. If there's a rolling into the inside of the bin, R will be 0. R means the reaction force, the contact reaction between the outer tire and the rod. It will be 0. Is that clear? If it is clear, please raise the hand. If you got that part, please raise the hand. I need responses from everyone. So you know this thing. You know this thing. Here we mean it is where V square means it is a positive value. V square is a positive value. H also positive. R A also positive values. G also positive values. Therefore, as all the quantities, all the physical quantities are positive values, definitely R will never be equal to 0 because there's plus sign. There's a plus sign. Therefore, all these values are higher than 0. V square is a positive value. V square is a positive value. H is a positive value. R, A, all are positive values. Therefore, R will never equal to 0. R will never equal to 0. Because all these values, V square, H, R, A, all are positive. Is that clear? If you got this one, please raise the hand. R කියන එක කවදාවත් 0 වෙන්නේ නැහැ. Thank you. That means this second scenario will never happen. That means if although there's a rolling, that rolling will not be happen into the inside of the bend පුතේ. bend එක ඇතුළට කවදාවත් පෙල්ලෙන්නේ නැහැ. bend එක ඇතුළට කවදාවත් පෙල්ලෙන්නේ නැහැ. කවදාවත් ඔයගොල්ලෝ අහලා නැහැනේ. බයිසිකල් එකක් එහෙම පෙල්ලෙනකොට මේ වංගුව ඇතුළට පෙල්ලෙන අහලා නැහැ. වංගුවෙන් එළියට තමයි අනිවාර්යෙන් පෙල්ලෙන්නේ. bend එකෙන් එළියට. ඒ නිසා bend එක ඇතුළට කවදාවත් පෙල්ලෙන්නේ නැහැ. roll වෙන්නේ නැහැ. roll වෙන්නේ නැති වෙන්න reason එක තමයි අපි පෙන්නේ. හරිද? දැන් අපිට කියන්න පුළුවන් reason එක. මෙන්න reason එක. මේ reason එක නිසා no, there's no rolling into the inside. But there's a negative sign here. So somehow, if G is equal to this value, then definitely S becomes 0. If S becomes 0, definitely there will be a possibility of rolling into the outward direction. Is that clear? Okay. So Pute, if there's no rolling, definitely S should be higher than 0. Definitely should be higher than 0. If there's no rolling, definitely inner reaction between inner tires and the rod should be higher than 0. Otherwise, there will be a roll. So this is the condition. Then the critical or the limiting condition is S higher than or equals 0. Equals 0 means that is the limiting condition. Limiting means that is the minimum requirement. So S කියලා කියන්නේ මේක පුතේ therefore m over 2 times g minus v squared over h. Okay, so this part is anyway higher than 0. Therefore, this part will. So if you take this term into that side, and if you subject v squared, කියන්න පුළුවන් මම මේ ටික දාගත්තොත් හොඳයි. හරි. No need to write anything, but write this topic. Rolling of a car at a bend කියලා මේක දාගන්න. මොකද ඔයගොල්ලන්ට මතක් වෙන්නත් එක්ක මේ වැඩේ කරන්න. හරිද? ලියන්න අවශ්‍යතාවයක් නැහැ. මොකද මම නෝට් එක දීලා තියෙන්නේ. මේක තමයි. ටග් ගන්න. ඔය එකේ මේ ටික දාගන්න පුතේ මොකද නැත්තම් කොහොමද කරේ කියලා ඔයගොල්ලන්ට මතක නැහැ. කියන්නේ මේ ක්වෙස්චන් එක. මේක දෙකක් වගේ නේද? ක්වෙස්චන් එකක් වගේ. වෙනස හදාගන්න. මම ඒක විතර කිසිම දෙයක් මම ලියුවේ නෑ කියන්නේ ලොජික්ස් ෆෝමියුලා විතර ලියන්න ගියේ නෑ මොකද නෝට් එකේ තියෙනනේ දින. ඒ නිසා ආයි අවශ්‍යතාවයක් නෑ මට පොඩ්ඩක් කරන්න. කොහොමද කරේ කියලා හුරු වෙන්නත් එක දාන්න. හරි. So it is very clear G minus V square H over RA higher than or equal 0. That means if you take this term into the other side, V square H over RA is smaller than or equal G. On the other hand, I can write this one. V is smaller than or equal RGA over H square root. Therefore, if the velocity is lesser than this value, if the velocity is lesser than this value, then there is no rolling. And on the other hand, I can say if this velocity is higher than, if this velocity is higher than this value, ARG over H, ARG over H. If the velocity is higher than that value, definitely this will roll into the outer direction, Okay. So the critical or limiting value means equal scenario. That means that is the limiting condition. That is the limiting condition. So that is the maximum velocity. That is the maximum velocity that can have by any vehicle in order to move in a bend without rolling. So the maximum velocity that can be have by a any kind of vehicle without rolling into the outward direction is equal to square root ARGO. This is maximum velocity. Maximum velocity without roll. So, if you know this value, you can adjust this value according to the geometrical configuration. According to the geometrical configuration of the vehicle Pute. You know, here H and A are related to geometrical configuration of this vehicle Pute. So H means it is the height from the ground to the center of gravity of the vehicle, and A means that is the width of the vehicle. A means width of the vehicle. Therefore, if we can increase the width, that means if we can increase the width, if we increase the width, what will happen? If we increase the width, maximum velocity will be increased. That means we can increase our velocity into higher value without rolling. And that's one may A කියන එක වැඩි කරොත් මොකද වෙන්නේ? If I increase A, Vmax also increase. Vmax increasing means we can move faster than the previous case. එහෙනම් මට වේගයෙන් යන්න ඕන නම් මම මොන වගේ ක්‍රම එකක්ද ගන්න ඕනේ? අනිවාර්යෙන් මගේ vehicle එක පොඩ්ඩක් පරාල වෙන්න ඕන. vehicle එක පොඩ්ඩක් පරාල වෙන්න ඕන. ඊළඟට ඒක රෝද වලට මෙතන center of gravity කියන දේ රෝද වලට තියෙන තුර. නැත්නම් vehicle එක ගොඩක් පරාල වුණා කියලා වැඩක් නැහැ. හරි center of gravity කියන රෝද වලට තියෙන තුර. ඒක නිසා තමයි ගොඩක් වෙලාවට අර මේ කාරවල අපිට රෝද අපි පන්නනවානේ. රෝද පන්නනවානේ ගොඩක් වෙලාවට කාර් මේක හදන්නේ. මේ රෝද පන්නන්න හේතුව ඒක තමයි මේ center of gravity කියන තියෙන distance එක වැඩි කරගන්න. Then S should be shorter. S should be shorter means height should be very short. Height to the center of gravity should be very short. ඒක තමයි මේ formula cars ගත්තොත් එහෙම ඒක ගොඩාක් පොඩි පුතිය. ඒක H තමයි ඒගොල්ලෝ ගොඩක් අඩු කරලා තියෙන්නේ. H ගොඩක් අඩු කරලා තියෙන්නේ ඒගොල්ලෝ. H ගොඩක් අඩු කරලා තියෙන්නේ. මේ formula cars ගත්තා මේ වගේ කියන්නේ ආයි. දෙලින්ම නැගිලා යන්න තියෙන්නේ. එතකොට H ගොඩක් අඩු කරලා තියෙන්නේ. H ගොඩක් අඩු කරන්න ඕනේ. A පුළුවන් තරම් වැඩි කරන්න ඕනේ. මොකද A වැඩි කරන එකේ limits තියෙනවා අපිට. මොකද A වැඩි කරොත් අපිට ස්පීඩ් එක ගන්න බෑ. අන්න ඒක තන්දර තියෙනවා. මොකද අර මේ aerodynamic කතන්දර වලට ප්‍රශ්න වෙනවනේ. ඒ නිසා A වැඩි කරන එකේ limitations තියෙනවා. ඒ නිසා තමයි H පුළුවන් තරම් අඩු කරලා. H should be decreased. Yes. If H should be decreased, yes. අනිවාර්යයෙන් H අඩු කරන්න ඕනේ. H අඩු කරපුවම අපිට ලොකු ස්පීඩ් එකකින් වංගු යන්න පුළුවන්. බෙන්ඩ් එක යන්න පුළුවන්. හරි. Okay. If you got this theme, please share the hand. I need responses from everyone. Okay. Shall I can online with you. Okay. Then next theory part. Next theory part is banking of rods. Banking of rods. Banking of rods. banking of frauds කියලා කියන අපි roads ගත්තොත් එහෙම ගොඩක් වෙලාවට අපි මේ නිකන් අපි incline කරලා තියෙන අපිට bend එකක් incline කරලා තියෙනවා. That is called banking of fraud. Banking of fraud means incline bends. Incline bends. Now suppose this is a bed. This is a cross section of a bed. This is a cross section of a bed. Now this bed is inclined. The inclined bend එක අපි සාමාන්‍යයෙන් ඔයගොල්ලෝ දැකලා ඇතිනේ. අපි සාමාන්‍ය formula tracks ගත්තොත් incline. ඊළඟට ඔයගොල්ලෝ දැකලා ඇති ඔය මේකද ඔය indoor cycling තියෙන්නේ. indoor cycling වලත් එහෙමනේ. පරිගාව ලොකු බෑන්ක් එකක් තියෙනවා. ලොකු inclination එකක් තියෙනවා. හරිද? ඒකට මම කියන්න දැන් හේතුව. හරිද? So banking of frauds can be divided into two segments. One is if there's a frictional force. If there's a frictional force, then we have to consider that force also. The other thing is smooth surface. Smooth surface means without friction force. Therefore, banking of rods can be considered into two segments, can be categorized into two segments. One is frictionless rods, other one is rough rods. Rough rods means rods with frictional force. Rods with frictional force. 아무도 that nothing for make it try understand. Suppose now there is no force, no friction here. So if there's no friction, Puthe, what will happen? Then definitely, now this is my vehicle. Now there's a perpendicular reaction perpendicular to the surface, and mg is into downward direction. mg is into downward direction. And so if I apply F equal mb into the center of the circle, center of the bend, definitely I have to resolve this force. I have to resolve this force. I have to resolve this force. You know, this angle is theta, therefore this angle is theta, therefore this angle is 90 minus theta, therefore this angle is theta, this angle is theta. Theta. This angle is theta, therefore this angle, maybe z everything, this angle is theta, therefore this angle is 90 minus theta, therefore this angle is theta. So, into the upper direction, force is r cos theta. Into the center, force is r sin theta. If you got this one, please raise the hand. Forces. Now this is a smooth surface. Now, if I apply F equal mb into the center, if I apply F equal mb into the center, now there's only one force F sin theta, sorry, r sin theta is equal to ma. Ma means b squared of r. And if I apply F equal ma into the upward direction, r cos theta should be equal mg. R cos theta should be equal to E. R cos theta should be equal to G. Therefore, if I divide 1 by 2, if I divide 1 by 2, tan theta is equal V squared over RG kilogram. V squared over RG kilogram. Is that clear? Make a question. If you got this calculation, please raise the hand. Okay. Then we can consider the other case. Other case means friction with friction case. With friction case. Balance friction have down. Maybe you know that very well. Maybe okay, you know. So if there's a friction, okay, now what will happen? This vehicle tries to move away. This vehicle tries to move away from the center. And therefore, friction force should be exerted into the downward direction because this vehicle tries to move away from the center. As a result of that, friction force is occurring to the downward direction. F. And this value is theta. Therefore, here, if I resolve the forces into the center of circle, there are two forces. One is r sine theta, other one is f cos theta, r sine theta, and f cos theta. So if I apply F equal ma into the center of circle, here the force is r sine theta, one force is r sine theta. You can resolve r as well as f with f can be resolved into that direction. F cos theta should be equal m v squared over r. If you got this one, please raise the hand. I need responses from everyone. I need responses from everyone. If any student did not get this thing, please raise the hand. Raise the hand means please let me know. Ramdi, Hardik. Okay. That's it. Hardik. Okay. Then I can write equation for vertical forces. Now there are several vertical forces. No, one is r cos theta into upward direction. That should be equal to mg plus f sine theta. That should be equal to mg plus f sine theta. F sine theta is into downward direction. F sine theta plus mg equal r cos theta. Because there is no vertical movement. Okay, now this is a circular motion. No? So as it is circular motion, this object always tries to move away from the circle. Circle එකෙන් එළියට යන්න බලන්න වේග වැඩි වෙනකොට. Circle එක ඇතුළට එන්නේ නැහැ. Circle එක ඇතුළට වෙන අවස්ථාවක් තියෙනවා මේකත් කතා කරන්න. වේගය වැඩි වෙන අවස්ථාවක් මේ කතා කරන්නේ. හරිද? මේක circle එක ඇතුළට වෙන අවස්ථාවක් තියෙනවා. මම ඒක වෙනම කතා කරනවා. වේගය මං හිතන්නේ වේගය ටිකක් වැඩි කියලා. වේගය වැඩි වෙනකොට circle එකකින් මොන පැත්තට යන්නේ පුතේ? එළියට. Therefore, if the velocity is in higher range, the object tries to move away from the circle. That means it tries to move away. Move away means into the upward direction. And therefore, friction force is exerted into the downward direction. And so that is due to the higher velocity, Pute. That is due to higher velocity. If the velocity is lower value, then there is another scenario. I will discuss that separately. Okay? Is that clear? Arda Okay. Okay. Then suppose now if it is a limiting condition. So if it is a limiting condition, Pute, if we equal mu r, no, if it is in limiting condition, if we equal mu r, and if we know what mu r done for, if we know mu r done for, therefore from 1 I can write r sine theta plus mu r cos theta is equal m v squared over r. From 2 I can take it here, take it into here. R cos theta minus mu r sin theta is equal mg. This one is 1, this one is 2. So if I divide 1 by 2, R, all are common factors, therefore I can cancel out R. So if I divide 1 by 2, sin theta minus mu cos theta divided by cos theta minus mu sin theta is equal V squared over Rg. V squared over Rg. And then I can divide each term. I can divide each term by sin theta. Sin theta what is the divide term? Then sin theta over sin theta minus mu sorry, sin theta cos theta will be divided. Cos theta. Tan theta and sin theta or cos theta. Sin theta over cos theta minus mu cos theta over cos theta divided by cos theta over cos theta. Is that a class name? Mu sin theta over cos theta. So that is equal to V squared over Rg. Sin theta over cos theta is put a tan theta. Therefore, tan theta made by capital plus mu made by capital of the 1. Therefore, tan theta plus mu over 1 minus mu tan theta is equal V squared over Rg. V squared over Rg කියලා. හරි. එහෙනම් මෙතනින් මට maximum speed එක calculate කරන්න පුළුවන්. මොකද මේ limiting condition එක ගත්තේ පුතේ. limiting condition එක ගත්තේ මේ V වල maximum එක තමයි මෙතන එන්නේ. And therefore V squared is equal RG into this term. Is that clear? If it is clear, please raise the hand. තේරුණා තුෂ්ෂන්? පැහැදිලි වෙනවද තුෂ්ෂන් calculation? පැහැදිලි? Okay. No need to write down this thing. Those are in the tute. If you want to write any additional information, you can write down this thing. If you want to write any additional information, you can write down this thing. No need to, otherwise, no need to write. Ah, බලන්න ඊළඟ ඊළඟ තමයි මම අර අනිත් scenario එක මොකද්ද? If now suppose now there's a banking of fraud. Now this fraud is bank. Now suppose if there's a sliding down means if the vehicle moves in downward direction due to a insufficient velocity, then what is the requirement for that thing? What is the requirement to sliding down the vehicle into the downward direction? Most of the case that is because of lack of velocity. If the velocity is not sufficient to complete the full circle, it can be sliding down into the downward direction. වෙන්න පුළුවන්ද පුතේ? ඔයාලට දෙන්න පුළුවන් අපිට අර ස්පීඩ් එක නැත්නම් පරාට දෙන්න පුළුවන්. ඔයගොල්ලෝ අර දැකලා තියෙනවා නේද? වලේ මෝටර් සයිකල්. දැකලා තියෙනවද වලේ මෝටර් සයිකල්? දැන් තියෙනවද දන්නේ නැහැ. පොඩි කාලෙකින් දැකලා නැහැ මාත්. දැකලා තියෙනව නේද? ආ. ඒ වලේ මෝටර් සයිකල් එක මොකද වෙන්නේ? ඒත් ඔය වගේ නේද? බෑන්ක් කරලානේ තියෙන්නේ. ඒක බෑන්ක් කරලා තියෙන්නේ. හරිද? එයා යන මේ මොකද්ද මේ ඔය මේ වල අපි වල කියන එක ඒක බෑන්ක් කරලා තියෙන්නේ. ඒක බෑන්ක් කරලා ඔන්න විදියට කරලා මෙතන මොටර් සයිකල් එක. ඔය විදියට now this man moves in this kind of circle. Only the circle එකක් නෑනේ පුතේ. This is the center. මාරකලින්ද සිස් මාරකලින්ද අපි කියන්නේ වලේ වෝටර් සයිකල් කියලා මාරකලින්ද කියන්නේ තොගරද. හරි. මාරකලින්ද කියන්නේ තොගරදයි. අර අපි කියන්නේ අපි පාවිච්චි කරනවා අපි වලේ වෝටර් සයිකල් මාරකලින්ද. එකක පැත්තේ එකක කතන්දර තියෙනවා නේ. එකක පැත්තේ එකක කතන්දර තියෙනවා. Okay. Now there's a reaction force. Now there's a reaction force here. ඊළඟට weight එක මෙයාගේ weight එක පල්ලෙහාට යනවා. So due to this reaction force, suppose if this angle is theta, if this angle is theta, this angle is theta, therefore this angle is 90 minus theta. Then to this side, if I apply F equal ma into this side, then r sine theta is equal mv squared over r. Okay. මම මෙතන friction force එක ගත්තේ නෑ. friction force එක ගන්න පුළුවන්ද? friction force එක තරගෙන කරන්න ලේසි. friction force එක ගන්න. මෙතන තමයි friction force එක අවස්ථා දෙකක් ගන්න පුළුවන්. ඒ කියන්නේ velocity එක වැඩි වෙනකොට friction force එක පල්ලෙහාට එන්නේ. velocity අඩු වෙනකොට friction force එක ඉස්සලා ගියොත් ඉතින් උඩට එන්නේ. හරිද? එහෙම දෙයක් තියෙනවා. ඒක මේ වගේ. මම පල්ලෙහාට යන අවස්ථාවක් ගන්න velocity වැඩි වෙනකොට. Therefore friction force should be into this side. So this angle is theta today. This is friction force F that is in the downward direction. Friction force F is in the downward direction. And this angle is theta. Therefore, to this side, r sine theta plus F cos theta is equal m v squared over r. To upward direction, mg in downward direction plus F sine theta is equal r cos theta. අර කලින් කතන්දරේ තමයි අරකම තමයි අපි කලින් කිව්වේ. ඒ වගේම උත්තරයි. එහෙනම් මෙතන මොකද වෙන්නේ? උත්තරත් අර ඉදලා ගන්න පුළුවන් f equal mu r දාලා අර equation එක ගන්න පුළුවන්. So we can use f equal mu r. Ready? මේක බලන්න පුළුවන්. මේක ඔය වලේ මොන සැකල් වලට වලේ මොටරසයිකල් නැත්තම් මාර්ග විදුලිය කියන ඔක්කොම. දැන් මාර්ග විදුලිය කාට පුතේ දැන් මෙතන ඒක ඔයාලට හොඳට තේරුම් ගන්න පුළුවන්. බැරි වෙලා හරි මේකයි ස්පීඩ් එක අඩුවොත් මොකද වෙන්නේ? උඩ යන්න පුළුවන්. උඩ යන්න බෑ ඌ පල්ලෙහාට ලිස්සනවා. ඌ පල්ලෙහාට ලිස්සනවා. ඒ වගේ තමයි පුතේ මෙතන if the velocity is not sufficient, if the velocity is not sufficient, then the vehicle cannot move in this circular path. It can be sliding down. It can be sliding down. Therefore, in such cases, friction force is into upward direction. In such cases, friction force is into upward direction. So this is the normal reaction. And this angle, whether theta here 90 minus theta, therefore this one is theta. AMG. AMG. Okay. ඔන්න මෙතන ලස්සන කතන්දරයක් තියෙනවා. මෙතන ලස්සන කතන්දරයක් තියෙනවා. හොඳට තේරුම් ගන්න ඕනේ කතන්දරය. හරිද? බලන්න. How to apply F equal MA? How to apply F equal MA along the inclined surface, along the inclined plane? How to apply F equal MA along the inclined plane? Inclined plane එකට කොහොමද යන්නේ? Inclined plane එක දිගේ කොහොමද අපි මේක දාන්නේ? Look at this one. In such cases, මේ වගේ තැන්වලදී අපිට use කරන්න පුළුවන් එක තමයි දැක්තාවුදී inclined plane එක දිගේ මේ F equal MA දාන්න. So if you want to apply F equal MA along the inclined plane, you have to determine what is the corresponding acceleration along the inclined plane. You have to determine what is the corresponding acceleration along the inclined plane. Look at this one. How to determine the acceleration? How to determine the acceleration along the inclined plane? Now you know this is our circle. This is our circle, Puti. This is our circle. Now here this is the vehicle. You know if this vehicle moves in this path, definitely there is a acceleration towards the center. That acceleration is towards the center, Puti. Therefore, that acceleration is equal V squared over R, that is towards the center. Therefore, when you are determining horizontal circular motion, when you are determining horizontal circular motion and applying F equal MA into an inclined direction to the horizontal, then definitely there will be a component of centripetal acceleration to the and until now, until now we have applied F equal MA into only two directions. One is into the center, other one is perpendicular to center. One is into the center, into the direction of center, other one is perpendicular to center. So if you apply F equal MA perpendicular direction to the center, then there won't be any component of centripetal acceleration. But if you apply F equal MA inclined direction to the center, then definitely there will be a component of centripetal acceleration. If you get my point, please raise the hand. If you get my point, please raise the hand. Look at this one. So if I resolve this component into along the inclined plane and perpendicular to the inclined plane. Perpendicular is inclined plane. There are two components. One is this one is theta, this one also theta. Therefore, v squared over r cos theta here, make a cos theta, make a sin theta. මතක තියාගන්න මේ ළමයි කරන ලොකු වැරද්දක්. මතක තියාගන්න මේ ළමයි කරන බාන්ති මතක තියාගන්න මේ ළමයි කරන ලොකු වැරද්දක්. මම කියන ලොකු වැරද්දක්. මේ perpendicular plane එකේ යනකොට මේ plane එකට perpendicular movement එකක් නැහැ කියලා හිතලා perpendicular forces balance කරන්න යනවා. ඒ කියන්නේ r sin theta cos theta. sorry r කියන එක equal කරනවා mg cos theta. r කියන එක mg cos theta equal කරනවා. කොහොම කරනවද? ඒ කියන්නේ along the plane දාන්න නැහැ ළමයි. ඉතින් along the plane ගොඩක් කරලා දාන්න මතක් වෙන්නේ නැහැ ළමයිට. හැබැයි ගොඩක් වෙලාවට ළමයි මේ inclined plane එක දීපු ගමන් මොකද කරන්නේ? ඒගොල්ලෝ දානවා perpendicular plane. perpendicular plane f equal ma දානවා. perpendicular plane f equal ma දානකොටම තේරුම් ගන්න මෙතන තියෙන මොකද්ද? acceleration component එකක්. acceleration component එක කාගේද? v squared over r ගේ centripetal acceleration එකේ component එකක් තියෙනවා. ඒ නිසා අපිට නිකන් f equal ma දාලා නැත්නම් මෙතන forces equal කරන්න බෑ. මෙතන acceleration component එකක් තියෙනවා. we have to remember that part. And therefore, if I apply f equal ma into this side, this is mg cos theta into this side, mg sin theta. So if I apply f equal ma into the perpendicular direction, now it is very clear. Into the perpendicular direction of plane, inclined plane. Here there's r. F is perpendicular. Along the plane, therefore no need to worry about f, that is 0. Then other force is mg cos theta. That is equal m බලන්න මේ into this direction. Now there is a velocity, acceleration, that is equal v squared over r sin theta. So if I apply f equal ma into the downward direction, along the plane, force is fb sin theta minus f. mg sin theta minus f is equal m. So into this direction, velocity is v squared over r cos theta. Did you get my point? If you get my point, please raise the hand. තේරෙනවා තුසන් මම f equal m දාපු හැටි. මම f equal m දාපු හැටි තේරෙනවා තුසන්. Okay, thank you. If you want to write if you want to apply F equal ma into the perpendicular direction of the plane, you can write down this thing. A perpendicular direction is done. Or not, you can write down a potato diagram. I shall put a diagram on map. You take that. Okay, look at this one. මේ මාර්ක ලියලා දාගන්න ඕන නම් notebook එකේ දාගන්න. මාර්ක ලියමු. අවුල නැහැ මේ forces ටික දැන් මොනි application එක ඔයගොල්ලෝ දැන් පුළුවන් වෙන්න ඕන. මොකද forces ටික මාර්ක් කරගන්න විතරයි තියෙන්නේ. ඊට පස්සේ අපිට ඕනි direction එකට resolve කරගන්න ඕන. හැබැයි මතක තියාගන්න හොඳට මතක තියාගන්න මම කියන දේ ඔයාලා incline plane එකකදී apply කරන්න යනවා නම් F equal මේ හොඳට මතක තියාගන්න. horizontal එකයි vertical එකයි apply කරලා කමක් නැහැ. හැබැයි incline plane එකට perpendicular නැත්නම් incline plane එකට parallel දානවා නම් F equal මේ මතක තියාගන්න අනිවාර්යෙන් there is a resolve component of centripetal acceleration. There's a resolve component of centripetal acceleration. Okay. හරි shall I erase? Now look at this now. No, it is along the plane, Puti. Make it. Yeah, make equation. Second equation is this one. It is where I have mentioned it is vertically in upward direction. Vertically up, not vertically. Along the plane into the upward direction. In this node, the second equation is applied in along the plane into the upward direction. It is not vertical force. Is that clear? So if I apply F equal ma along the plane into the upward direction, first force is F, other force is minus mg sine theta, and that is equal minus mv squared over minus minus නෑ හොඳට මතක තියාගන්න. equations දාන්න ඕනි vertical horizontal කියලා විතරක් නෙමෙයි මම ඒක නෙමෙයි මම කිව්වේ. ඔතන හොඳට මතක තියාගන්න. මේ මෙතනදී equations දාන්න ඕනි horizontally vertically කියලා විතරක් නෙමෙයි මම කිව්වේ. ඕනි පැත්තට දාන්න ඒක කිසි ප්‍රශ්නයක් නෑ. හැබැයි මම කිව්වේ you have to consider this thing. When you apply F equal ma into an inclined direction to the horizontal, then definitely there will be a resolve component of centripetal acceleration into that direction, because now this is a horizontal circular motion. Now this circular motion is a horizontal circular motion. Now this those circular motions are horizontal circular motions. Therefore, definitely its centripetal acceleration is in horizontal direction. V squared r is in horizontal direction. Therefore, if I apply F equal ma into the horizontal direction, that means into the center, then definitely some force should be equal to m v squared over r. That is rule number 1. Then if I apply F equal ma into vertical direction, there is no any other acceleration into the upward direction. Therefore, mg is equal to any other upward force. And so those are two occasions, or those are two options. Not only those options, you can also apply F equal ma into some inclined direction to the horizontal. You can apply, but remember this thing. When you are applying F equal ma into an inclined direction to the vertical or horizontal, definitely there will be a component of v squared r into the direction. Therefore, first of all, you have to determine what is the component, what is the resolved component of acceleration into that direction. After that, you can apply F equal mv. Is that clear? පැහැදිලිද? F equal mv අර ඕන පැත්තකට දාන්න පුළුවන්. කිසිම ප්‍රශ්නයක් නැහැ. F equal mv කියන එක ඕනම පැත්තකට දාන්න පුළුවන්. හැබැයි මතක තියාගන්න දාන පැත්තට තියෙන forces ටික වදනන් ඉන්න ඕනි. දාන පැත්තට තියෙන accelerations වදනන් ඉන්න ඕනි. එච්චර. පැහැදිලිද? තේරෙනවද පුතේ? මෙමාගේ තමයි කියන්නේ. මෙයාට perpendicular direction එක දැම්මා. එතකොට එන්නේ r minus mg cos theta is equal m මේ පැත්තට තියෙන acceleration component that is equal v squared over r sin theta. And ඊළඟට අපිට ඕන downward direction එක දාන්න පුළුවන් නැත්නම් upward direction එක ඕන එක කවුලක් නෑ. If I apply F equal ma along the plane into downward direction, here force is mg sin theta minus f is equal to mv squared over r cos theta. mv squared over r cos theta. ඒක note down කරගන්න පුතේ කොහේ හරි එතන එක්කෝ එතනම දාගන්න පුළුවන්. අපි මගේ note එකේම tute එකේම ඕන දාගන්න එතන ඉඳ තියෙනවා. මේක දාගන්න. We can apply F equal ma into any direction. We can apply F equal ma into any direction. But when applying F equal ma, into any inclined direction, to the horizontal, into any inclined direction to the horizontal, we should resolve v squared over r. We should resolve v squared over r within bracket centripetal acceleration. Within bracket centripetal acceleration into that direction. Into that direction. Okay. Then look at this one. Look at the last sentence. Can anyone may tell me the last sentence? Last sentence. Last sentence I got to get one of it. Yeah. Read it. Cover it. Last sentence.
But when applying it into an inclined direction to the horizontal, we should resolve v squared over r into that direction.
Okay. But when applying F equal ma, but when applying F equal ma into any inclined direction, but when applying F equal ma into any inclined direction to the horizontal, but when applying F equal ma into any inclined direction to the horizontal, we should resolve v squared over r. We should resolve v squared over r within the bracket centripetal acceleration. We should resolve v squared over r within the brackets centripetal acceleration, close the bracket, into that direction. Okay. Then now it is very clear if there's a sliding down, now friction force should be into the upward direction. If there's a sliding down, friction force should be in upward direction. If there is sliding down, air should be in upward direction. And left side upward direction. Therefore, if there's no sliding down, F should be in downward direction, Puti. Therefore, if there is no sliding down, that means if the vehicle has an enough velocity, then it won't be sliding down, Puti. So in such cases, velocity is in higher range. So F should be in other direction. Therefore, if there is no sliding down, then the velocity is higher. Therefore, F should be in other direction. Therefore, if there is no sliding down, definitely F should be negative. Negative means it should be in other direction. Is that clear? If you got my argument, please raise the hand. Now you can subject F from here. So if is equal, mg sin theta minus m v squared over r cos theta, that is F Puti. This is F. So this is F. And it should be negative. So if it is negative, then there is no sliding down. That means mg sin theta should be lesser than mv square cos theta over r. M12 will be cancelled out. Method tan over r gr tan theta for v square is higher than gr tan theta. That means if the velocity is higher than gr tan theta, if the scarf velocity is higher than gr tan theta, then then there's no sliding down. There's no sliding down. If v squared is higher than v squared higher than again, that is high velocity. So if v squared is higher than this velocity, gr tan theta, then there's no sliding down, then there will be a tendency to move the vehicle towards the outside direction, outside, towards the outside. Is that clear? If it is clear, please raise the hand. තේරුණා තුස්සාට? Good. ඔබ තමයි ඔබ තියෙන්නේ no need to write. මේ ලියන්න දෙයක් නැහැ. හරි. මේකද පුතේ? මේකද? ලාම්බි? මේකද? බලන්න පුතේ මේ. දැන් F කෙනෙක් කෙනා දැන් මෙයා ස්ලයිඩ් එක පල්ලෙහාට ස්ලයිඩ් ඩවුන් වෙනවා නම් පුතේ F කෙනෙක් යා උඩට ඉන්නේ. එයි පල්ලෙහාට බෑ යවන්නේ ෆ්‍රික්ෂන් ෆෝස් එක උඩට එන්නේ. හරි. එහෙමනම් බැරි වෙලා හරි මෙයා ස්පීඩ් එක වැඩි වෙනවා. මේ vehicle එකේ ස්පීඩ් එක වැඩි වෙනවා මෙයා එළියට යන්න බලන්න. ස්පීඩ් එක වැඩි නම් එළියට යන්න බලන්න. To outward direction. So if the speed is higher, value, then this vehicle tries to move in upward direction. Upward direction means into the outward direction. Then the friction force should be in other way. It should be in other way. Therefore, if the speed is enough, and if this vehicle tries to move in outward direction, the friction force should be in downward direction. එක ඉන්නවනේ පල්ලෙහාට. මෙයා උඩට යනවා නම් පුතේ කියන්නේ මෙයා එළියට යනවා නම් මේ වංගුවේ. මේක වංගුවක් පුතේ. මේ වංගුව මේ. මේ වංගුවේ පුතේ මෙයා එළියට යනවා නම් අනිවාර්යෙන් friction force එක තියෙනවනේ මොන පැත්තටද? downward direction එකට. ඒක තේරෙනවද? If you got the top. පැහැදිලිද? හරි. ඒ කියන්නේ මොකක්ද? එයා එළියට යනවා කියලා කියන්නේ ස්ලයිඩ් ඩවුන් නෑ නේද පුතේ? ස්ලයිඩින් ඩවුන් කියලා කියන්නේ එළිය නෙමෙයි අතුරට එන්නේ. හරිද? ස්ලයිඩ් වෙනවා කියලා කියන්නේ මෙයා අතුරට එනවා කියන්නේ. එළියට යනවා කියන එක නෙමෙයි. හරි. එතකොට මෙයා එළියට යනවා කියලා කියන්නේ එයා ස්ලයිඩින් ඩවුන් වෙන්නේ නෑ. Therefore, if there's no sliding down, F should be in other direction. Definitely F should be in other direction. මේ පැත්තට තමයි F තියෙන්නේ. If there's no sliding down, F should be in other direction. That means this F value should be negative. මේ F value එක negative වෙනවා. Direction එක මාරු වෙන්න කැමති. Direction එක මාරු වෙන්න. Therefore, this F value should be negative. This F value should be negative. So if I got negative F value, that means there is no sliding down. Is that clear? Parallel. එහෙනම් පුතේ බලන්න F value එක negative කියලා කියන F කියලා මේක නෙමෙයි. From this we can subject F. F is equal මෙයා මේ පැත්තට කියන්නේ mg sin theta minus m v squared over r cos theta. That is it. Therefore, this value should be negative. So you can take this value to this side. Then mg sin theta lesser than mv squared cos theta over r. Then m will be cancelled out. Then v squared is equal gr sin theta over cos theta means tan theta. Sin theta over cos theta means tan theta. Therefore, v squared is equal gr cos theta. V square is higher than GR cos theta. Therefore, if the square of velocity is higher than GR tan theta, then definitely this object will not slide down. It will not slide down. And there is a possibility of moving away from the circle. Is that clear? Slide down වෙන්න මේක velocity වැඩි වෙනකොට slide down වෙන්නේ නැහැ. හරිද පුතේ? හ්ම්? හරි. අපි දන්නවනේ අපි අනිවාර්යෙන් හිමින්සර යවුවොත් නේ පුතේ අනිවාර්යෙන් පල්ලහැට වෙන්නේ. වේගය යවුවත් පල්ලහැට එන්නේ නැහැ. ඒ නිසා velocity මොකටද කරා වැඩි වෙන්න ඕනේ. වැඩි වුණොත් තමයි slide down වෙන්නේ නැත්තේ. හරි. So if you want to write anything, you can write. හරි. last part එකත් අපි කතා කරමු. කතා කරලා questions වලට. The last part is this one, okay? Suppose now there's this is another application. Cylindrical vessel, and now this vessel is rotating about its own axis. This way, cylinder rotating, the cylinder is rotating about its own axis with a constant angular speed of omega. Now, suppose there is an object here. This object might be a man, might be any kind of object. දැන් මොකද වෙන්නේ මේක rotate වෙනකොට මොකද වෙන්නේ මේක rotate වෙනකොට move ඉන්න ඕනේ here. Yeah. Then what are the forces acting on this object? Suppose this inner surface is a rough surface. So what are the forces acting on this object? Definitely the normal force, normal reaction. Then as this one is in rough surface and this object tries to move in downward direction, therefore friction force should be in upward direction. That is friction force. And mg should be in downward direction. So those are the forces acting on this object. So actually, Bhute, when you are given any kind of question to be solved in circular motion, the first thing you have to do, you have to mark all the forces exerted on this object. Then identify the center. So if you want to apply F equal ma into the center, F equal ma, you have to resolve all the forces into that direction. And acceleration is equal to centripetal acceleration. If you want to apply F equal ma into any direction, you can resolve all the forces into that certain direction, in that particular direction. Then, after that, you have resolved the centripetal acceleration into that direction too. If your choosing direction is perpendicular to the centripetal acceleration, no need to worry about. That means if the centripetal acceleration is in horizontal direction, you are considering vertical forces, then there will not be any effect of the centripetal acceleration to such directions. But other than perpendicular direction, if you choose any other direction, you have to resolve not only forces but also the centripetal acceleration. Is that clear? That is the only thing you have to consider. ඒ නිසා මේ application එක මොකක් වුණත් කොහොම තමයි අපිට යන්න වෙන්නේ. මුලින් forces එක mark කරගන්න. එච්චරයි. So once you mark the forces, then you can apply F equal ma into this direction, into center. Okay. Now F is R. This is the centripetal force. This is centripetal force. This is centripetal force. R is equal M R omega square. Now we are given omega. M R omega square. And you know, friction force should be equal mg because there is no sliding down here. If there is no sliding down, F should be equal mg. F should be equal mg. And you know, if we consider friction force, any kind of friction force, any friction force is equal or lesser than the maximum friction force. Maximum friction force of limiting friction. We call it as limiting friction. F star. Therefore, any friction force is equal or lesser than mu r. Equal or lesser than mu r. And when there is a limiting condition, friction force is equal to mr. Other than that, friction force is lesser than mu r. Now you know what is friction force. This is mg. Okay. Therefore, mg is lesser than mu. R means m r omega square. So m12 will be cancelled out today. Therefore, omega square should be equal or higher than G over mu r. G over mu r. G over mu r. Have the omega square is equal or higher than. Equal or higher than means now there is a minimum omega value. Equal or higher than. Equal again, equal. That means there should be a minimum omega. There should be a minimum omega to this cylindrical vessel to avoid sliding down of this object. Otherwise, this object cannot be in equilibrium condition at this position. Because there is no any other way to put up. We cannot keep an object like this. No, we will have object at the end. Bad. The object at कोई भी तिया करना मत करना और एक को अभी वेगिंग कर करना. एक को बोलो देखते लेते हैं. अभी मैं कर मीटर के तिया ला वो टिक बोल करे का मीटर कर कर आगे वैसे लेके तिया. मुकदमे नहीं. अभी निकाल में बात करेगा कि तिया भी कर को मुकदमे नहीं. අනිවාර්යෙන් කරගෙන ස්පීඩ් එක තියනවානේ. ඒ ස්පීඩ් එක අඩු වෙනකොට මොකද වෙන්නේ? ඕක හිමින්සරේ ඇවිල්ලා ටොක් ගන්න ඉතින් සෙන්ටර් එක. ස්පීඩ් එක තියෙනකන් ඕක යනවා. එහෙනම් අනිවාර්යෙන් මේ වගේ සර්කියුලර් මෝෂන් එක මේ විදිහට තියෙන්න නම් අනිවාර්යෙන් මිනිමම් ඔමෙගා කියලා තියෙනවා. මිනිමම් ඔමෙගා එකක් තියෙනවා නැත්නම් එයා ඔය විදිහට ඉන්නේ වැටෙනවා. එහෙනම් වැටෙන්නේ නැතුව මෙයාට ඉන්න පුළුවන් මිනිමම් ඔමෙගා වැලියු එක. Omega minimum value should be square root g over mu 1. So this is the minimum omega value. That is the minimum omega value that should actually there is a minimum omega value of this cylinder to avoid sliding down of this object. To avoid sliding down this object. Is that clear? If it is clear, please raise the negative on to some. පැහැදිලි ළඟ තුස්සක්. හරි. ඔතනින් අපි මොකක්ද horizontal circular motions ටික ඉවරයි. ඒ applications ටික කතා කරා. දැන් අපිට vertical motions ගැන තමයි vertical motion නම් මහලු දෙයක් නැහැ. මහලු දෙයක් නැහැ කියන්නේ කතන්දර ටිකක් තියෙනවා. ඒක අර එකම දේ තමයි ඉස්සරහට ලැබෙන්නේ. මේ වගේ අර වෙනස් applications නැහැ. මේකෙත් ඉතින් අපිට කතා කරන්න දේවල් වලට ඉෆෙක්ට් තමයි පිටුරුව කොහොමද F equal එක දාන්න තමයි. හරි. Okay. Today now you can go through this tube. Take this tube. Tube number, home assignment number 3. Home assignment number 3. Okay, now you can try first 4 questions. Sorry, not first 4. 1, 2. Question number 1. Yes, first 4. First 4 currently. Only for first 4. First 4 questions. First 4 questions. Okay, while doing these questions, you can take a small water break. And මේ questions කරන ගමන් ඔයගොල්ලන්ට පොඩි break එකක් ගන්න පුළුවන් අවශ්‍ය නම් water break එකක් අරගන්න පුළුවන්. questions එක කරන ගමන් හොඳයි. හරි. If you want to write down this thing, you can write down this thing. මම මේ විදිහට නෙමෙයි අත්තන හදලා තියෙන්නේ. ඒ නිසා ඕනනම් මේක දාලා යන්න පුළුවන්. හරි. මොකද දැන් ආයේ අලුතෙන් ලොකු break එකක් දීලා ආයෙසරක් ඇවිල්ලා කරන්න ආයේ තේරුමක් නැහැ. මේක අපිට discuss කරලා එකපාර ඉවර කරන්න පුළුවන් මේ පාඩම. Therefore, if you want to have a little water break, you can take, but while doing these questions. Okay. Have finished? First question. First question. Two particles with masses of mkg and capital Mkg are attached to ends of inaccessible string of length 3a. The string passes over a smooth pin located at point O. The particle with mass simple m moves in a horizontal circle with an angular velocity of omega radius per second. The particle m is at center C of the circle. OC distance is A. Show that 2m is equal. करा देंगे. If you complete question number 1, please raise the hand. Okay. Now you are given this kind of figure. Here there is simple M mass. There is capital M mass. And this height is A. There's a tension force T. This tension force T, and tension force here T. Then the angle with the vertical is alpha. As the total length of this string is 3a, the hypotenuse should be 2a. Hypotenuse should be 2a because the entire length of the string is 3a. Yes. Yeah. Now it is very clear. Number 1. We have to show that 2m m is equal, capital M is equal to a. Okay, look at this one. Now it is very clear. If we consider now the vertical equilibrium of capital M, tension force should be equal mg. So if I can consider about vertical equilibrium of capital M, capital T should be equal mg. That is number 1. Okay. Then, if we consider about this arrangement, T cos alpha should be equal mg. Therefore, if I consider about vertical equilibrium of simple M, T cos alpha should be equal simple mg. Cos alpha means, so here this one is A, adjacent side is A, hypotenuse is 2A, therefore cos alpha should be equal half. It should be half. So therefore T over half should be equal mg. T means with a mg, therefore mg, capital Mg over 2 is equal simple mg. M will be cancelled, sorry, not M2. G will be cancelled out, therefore m is equal to simple. So simple. Okay. Then, second question. Tension force is equal to Am omega square, 2A omega square. Then we can apply to the center of the circle for simple M. We will apply for simple M into the center of the circle F equal to M. F means sine theta. F means T sine theta. Sine theta means sine alpha is equal M R omega square. M R omega square. Now you need to determine R, okay? You need to determine R. R, you know R is equal to A sine alpha. R is equal to A sine alpha. Therefore, instead of R, I can write 2A sine alpha. Therefore, T sine alpha is equal M 2A sine alpha omega square. Therefore, sine alpha will be cancelled out. Therefore, T is equal to MA omega square. If you got that term, please raise that. Okay. Then the second question. Two particles with mass simple M and capital M are connected by an inaccessible string of length simple L. Particle capital M rests on a smooth horizontal. The particle capital M rotates in a horizontal circle around O with angular velocity of omega radius per second. Show that the vertical distance from O to particle simple M is given by unknown. Again, x quantity. X quantity. Now you are given this kind of figure today. Here capital M. Here simple. So this length is x and this radius is L minus x. Now this particle is in on a smooth horizontal table. Therefore, if I draw the plan view, it should be like this. This is 0.4. This is L minus x. And capital M particle rotates in a circular path like this. It rotates circular path like this. Yeah, maybe circular path now with the omega speed. Okay. So you need to determine x. X. Okay, now it is very clear. This that's tension force T. That one also T. Here T. And then T for two. So if you consider about the vertical equilibrium of simple M, if we consider vertical equilibrium of simple M, definitely tension force should be equal to mg. Tension force is equal simple M into G. Then if we consider about the rotation, or if we consider about the circular motion of capital M, then I can apply to this direction to capital M F equal M. So if you consider about capital M, there's only one force into this side, that is T, that is centripetal force. So centripetal force is T is equal capital M R omega square. Now tension force is simple mg capital M. R means L minus x, that is the radius. That is the radius of the circle, L minus x. L minus x omega square. L minus x omega square. Therefore, L minus x is equal mg over capital M omega square. අපිට මොකක්ද පෙන්නන්නේ? හරි. එහෙනම් මේක මේ පැත්තට දාලා මේක වෙන පැත්තට ගන්න x is equal L minus mg over capital M omega square. So if you consider about the common denominator, x is equal capital M, whether L M L M omega square minus mg over M omega square. If you got this answer, please press then my answer again for question. ගණිත එකයි Is it okay now? Did you get this thing? Then not. If you get my explanation, please raise the hand. They don't understand. Okay. Then that done. What is done? The mass of 0.1 kg is connected to one end of a string of length 1 meter and it is rotated around a circular path of radius 20 centimeter. At 1.2 ms minus 1 uniform velocity by having other end fixed. Find the tension of the string. Now this is a conical pendulum because length of the string is simple measure 1 meter. The length of the string, is 1 meter and radius is 20 centimeter. This is 20 centimeter. And this one is 1 meter. 1 meter means 100 centimeter. Suppose if this one is theta, this angle also theta. Now this pendulum rotates in this kind of circular path at a speed of 1.2 ms minus 1. You are asked to determine the tension force of the string. And the tension force. Now, as I mentioned earlier, you have to mark all the forces exerted on the moving object. So now the tension force is one force, other force is mg. So those are the only forces exerted on the moving object. And m is 0.1, m is 0.1 kilonewton. That means mg is 1 Newton. So if I apply F equal ma into this side, T sine theta, I have a tension force now. Yes, yes, okay. T sine theta is equal m v squared over r. M v squared over r. Therefore, T into sine theta means 20 over 100. 20 over 100 means 105. 105. 20 over 100 means 105. Is equal, mass is 0.1. Mass is 0.1. V square means 1.2 square. 1.2 square over R means 0.2. 0.2 meter. එහෙනම් මෙතන එනවා පුතේ T is equal මෙතන එනවා කීයද 1.44 over 2 that means 0.72 0.72 1.44 1.44 over 2 means 0.72 into 5 when I'm entering පුතේ and then you got it this 3.5 Newton. 3.5. Sorry, 3.6 Newton. 3.6 Newton. This is for question number 3. Then question number 4, the maximum velocity with which a vehicle of mass 400 kg can move on a circular track with a friction without sliding away is 10 ms minus 1. This is a horizontal track. Okay? If radius of this track is 40 meter, what is the coefficient of friction between the vehicle and the track? This is fourth one. Now there's a vehicle like this. Here's the horizontal track. So this object moves at a maximum speed without sliding, that is 10 ms minus 1. V max is 10 ms minus 1. Now this object moves at the maximum velocity without sliding. Maximum velocity without sliding, that means this object is at limiting condition. So that is the maximum speed. And now here there's a friction force into this side. That friction force should be equal to mu r. It should be equal to mu r. And there's R here and mg here. So those are the forces exerted on this object. Mass here, see here. Therefore, mg is equal 40,000. Sorry, 4,000 Newton. 4,000. And radius R is 40 meter. Okay. So if I consider about the vertical equilibrium, R should be equal 400. R should be equal 400 Newton. Sorry, 4,000 Newton. 4,000 Newton. And if I apply equal MA into this side, force is mu into R means 4,000 is equal MA. M is 400 Newton, so 400 kilogram. Velocity, V squared over R. V squared over R means 10 squared over R. එහෙනම් මේක යනවා පුතේ කීයද 10යි මෙතන කිව්වොත් එහෙම 10යි 10 විදීම තව 10 කියන්නේ mu equal 0.25 or no fault. So this is third one, this is fourth one. If you get this thing, please raise the hand. Anything on to some minute. Regular motion අමාරු නෑ හොඳේ. අමාරු නෑ. Our next class is in this Tuesday. It is about waves. Waves. If I can do another class, on this Wednesday, I will let you know. And, if I can do a class on this Wednesday, I will start fluid part. Fluid part එක මම start කරනවා. මොකද ඕගොල්ලන්ගේ term test එකට කලින් ඒකත් පොඩ්ඩක් අපි අල්ලලා තියන්න ඕන නිසා. හරි. ඒ නිසා fluid part එක මම start කරනවා. fluid එකේ note එකේ මම soft copy එවන්නම් මට post කරගන්න වෙලාවක් නැති වෙයි. soft copy එවන්නම් hard copies ටික මම next week මම post කරන්නම්. හරි. මේ මොකද්ද ඒක fluid වලනේ. හරි. Have finished? Okay, Puti. Then we can complete today's class because after that we have to start another new lesson, vertical circular motion. That's why I did not give you any break. And break at දුන්නේ නැති එක දිගට දෙගෙන යන්න ඕන නිසා. හරිද? නැත්නම් break එකක් දුන්නා කැරෙනවා. Okay. Now we can complete today's class. Do you have any questions regarding today's lessons? Do you have any questions regarding today's lessons? Thank you. Okay, then as we discussed, our next class is in on next Tuesday. And if I do any another class, I will let you know. Another thing is the students who cannot come for Wednesday class, please let me know. Please let me know your free times. Then I will arrange another class for you. Okay, another class for you. Same content, but another day. Okay. Anyway, so we can finish today's class with you, everyone. Good night. Have one for you.
Thank you, sir. Good night, sir.
Okay, thank you.